Uh, as I said, welcome everyone. Welcome to today's lecture. So, without the waste of much time, our today's lecture to be based on the design of a beam. That is a continuous beam analysis and design of a continuous beam. So, what I am going to do first, I'm going to double click on my Tekla text. Then I will click on the first one, that is use the extensive library of calculations recommended for new users. But the down one, use the extensive library of calculation to create complete project report or written your own custom calculations. That is a plugins in Microsoft Word. When you click on the second one, it will open in Microsoft Word and then you will start your calculations automatically. So I will click on the first one. When I click on the first one, we will be patient for some few seconds. A dialog box will open again, launching the software. Then the software is launching now. So after it finished launching, another dialog box will bring from here, but we are going to exit such dialog box. That is this one. Then we are going to exit this one. Then we are going to start a new project. Then we are going to click on new. That is create a new document, or you can press Ctrl N in order to create the new document. When you click on the new, a dialog box will open. Then there are so many calculations here. Don't click on these beams. We are not going to deal with beam. That is, you will see IC beam analysis and design. Then we are going to go for concrete. When you double click on concrete, we will see what IC beam analysis and design. Then you will double click on this one and double click on the first one. So as an engineer, or as the designer, you are going to do the design of a continuous beam, you must know the number of the span and know the condition of the support, whether the support it is free or restrained, or it is roller, and so on. So when the dialog box open here, you will see a default normally one span with a length 80 meter. So what you are going to do, first, what you are going to do is to click on this geometry. When you click on the geometry, then you will see this first length here. When you are dealing with only one span, then you will edit this length and put the length according to your specification. But if you have multiple span, what you are going to do, you can click on this insert span, or you can click on this add span. When you click on this add span, another span will be added here, and you will see it in this position with a default length of 80 meter. Assume we have 3 span, then if you click this one, we have 3 span again. You will specify the length of the span, which is, we have 3.5, another 3.5. Let us say here we have 4 meter. It depends on the length that you have. Or if you have or if you have the same length, you can put all of the same length. You put the 4 meter here. Assume we have 4 meter here, and here let us say we have the 3.5 automatically. Then we will click. What the software it is doing, it is approximating the values into 1 decimal place. Yes, into no even decimal place. If you check here, we put 3.5, but here we have 4 meter as the length of the beam. But if you check the normal geometry by mere looking, that is physically, you know that from this support to this one, it is not equals from here to here. So that is what it is happening. Then when you put the length here automatically, just forget about the area here, because we did not set our width and thickness of the beam. In default, it is rectangle, so we are not going to enter anything here. The software will calculate by itself automatically. So when we come here, that is vertically, that is the support, that is the vertical support. You can change the support, whether it is restrained or it is free or it is spring. You can change everything from here. So when you come back to rotation, we know when it is a roller support, and there will be a rotation and other things, depends on the type of the support that you have. Or if you are going to restrain such structure from rotation, you click on this restrain automatically. You will see a fixed support here will come at these positions automatically. So when you have another restraint support at the middle, that is from span 1 to span 2, at the middle junction of span 1 span 2, you can click on the restraint here automatically. You will see the restraint support will be applied automatically to the software. Or we are going to take it back to free. It is free to rotate, but if you come here, that is the vertical reaction. There is difference between this rotation and the vertical reaction. And the vertical reaction is that when you have a free support here, whether that span it is cantilever, you just click on this drop down list and click on free. You will see the free end of the span will be free. That is, the span will be cantilever automatically, but we are not dealing with cantilever now. Is the choice is yours, the designer. It depends on your specification that you have on your structure that you are going to use. So we are going to take it back to the restraint and click on OK automatically. And then you will see the informations here as we put it on the first dialog box here. So then now we are going to set our loadings. When we click on loading, a dialog box will open. Then we are going to put our loads on the span. So when we click on the first span, depends on which load that you have or which load that you are going to put. Are you going to put dead load or live load? It depends on that one. So if you click on this first span, you will not see anything here. Then you click on add load. When you click on add load, here default we have dead loads, that is UDL. But when the load it is varied dead load, that is varied uniformly uniformly varied load. There is uniformly distributed load, uniformly varied load, there is point load, there is couple load, there is trapezoidal loads. When you have point load, you will specify the point load that you have, but if it is UDL, you click on this UDL. And then in this load 1, that is the dead load. What the software wants, it is only unfactored loads without any partial factor of safety. So what you are going to do, we have a dead load. Assume we have a 10 of dead loads. I'm just putting the values for you assumptions, but you as an engineer, when you distribute the load, or you have an issue with any other BIM software like Porter and even the Tekla structural designer, ETABS, STAAD.Pro, and so on, or Quick Civil series, you can come here and check and see what it is going to give you. So here it is 10, and then this +1, that is position of the load. As you see, it is what POS1, that is position, where it is going to start, where from this first span, from the 0, or that is from the endpoint to the other endpoint, or you have what we call part UDL. Those who are good in analysis and then the design of structures knows what is part UDL. Normally, we used to encounter those kind of issues, especially when you are dealing with residential buildings, load that are transferred from slab to beams. You will normally see those loads that they are part UDL on the beam. That is, they did not occupy the whole length of the beam. They occupy some certain position of the beam at that position. So that is on this one, then the load will start from the endpoint here and then to the other endpoint, which is 4 meter, and then click on enter. You will see the load here automatically, that is 10 kilonewton. So if we have a live load, when we click on add load, then on the drop down list here, you will click this one, the dead load, change it to imposed load, and put the imposed load that you have there automatically. That is the imposed load. Here, let us say we have 5 kilonewton per meter, and then the length, you can find it is a part UDL, or it will occupy the whole length of the beam 4, and then click on enter. You will see the dead loads and then the imposed load here automatically. So when you come back to span 2, you will not see anything, means we don't have any load on such span. We can click on add load. When you come back here, that is the dead load. Then what is the dead load on such span 2? Then you put the dead load. If we have any dead load like 15, and come back here, what is the position of such dead load from this place, which is 4 to, that is at the center, we have 3.5 to 7.5. There is no need of writing 4 here. Automatically, when you are in span 2, the software will know the certain position of the span, knows the certain position of the span, where the span 2 start, and then it will just start putting the load for you from that position. So here we are going to put just the total length, which is 3.5, and then click on enter, and then add load. We have a live load, impose load. Just say we have 10 kilonewton, and then put the other live load on the total length here, and then click on enter. Then you will see everything on the diagram there. Then when you click on span 3, click on add loads. The first one, let us see, we have a dead loads of 10, and then the total length will be 4, enter. And this one, say we have 5, and the total length will also be 4, and then enter. So here will be imposed load. So that is, we have that an imposed load automatically. So when you finish with this dialog box, if they say load case type here at the below button here, what they mean by this load case type, whether you have any other additional load on the beam, which is subjected to horizontal load like wind load or snow load. Normally in this our country in Nigeria, we did not used to experience such kind of issues. So we are going to click on OK here. So when we finish, we are going to set our load combination. So load combination depends on the total span of the beam. The larger the span, the higher the number of the load combination that you are going to do. Higher the number of load cases that you are going to do. So when you have, assume we have 2 span beams, then you are just going to adopt 3 load combinations. When you have 2 span beams, 3 load combination, 3 span beams, you can also work with 3 load combination. But when it goes to 4 span beam, the load combination will go higher, depend on the number of the span that you have. Those who are good in analysis will know such kind of things, and you must find the critical condition, the worst case condition of such structure. Normally, when you have a beam which have too much spans, the center support, it is the worst case condition at that position. Then you need to find the worst case condition at that support. That is to superimpose the adjacent span of the near to that support. Assume we have 4, then if you have another 4 here, that is the center support. That is span 2 and 3 will be fully loaded. That is 1.4 GK plus 1.6 QK automatically. So if you are going to work with only 1 load combination, which is this one, if you are going to add, let us say we have 2 load combination, then the first load combination will be both, all of the span will be maximally loaded. And the second load combination will be alternative loads. That is, the first span will be maximum, and the second will be minimum, and the third will be maximum. That is how it is going to be going. So on the first one will be maximum 1.4 times GK, 1.6 times QK, and the second one will be only 1.0 times GK without the imposed load. Then here will be 1.0, enter, and then if we don't want imposed load, click on 0, it will remove the imposed load. Then when you come back here, you will leave it like this, and this one like this, in order to find the worst case condition at the first span and the last span in this load combination 2. In load combination 3, the first one will be 1.0 GK, and then the imposed load will be 0, and then the second span will be fully loaded, and then the third span will be 1.0 GK, and then was 0 QK. Then that is to find the worst case condition at the center span now. So when you finish with such, there is a support, but we are not going to deal with support load combinations. If you like, you can edit the support load combination to put it the same as we have on the span. Then you click on OK automatically. Then we are going to set our moment distribution as we explained on our first lecture of designing a beam. We talk about moment distribution, which is the process of reducing negative moment at the support and increasing positive moment at the mid span. So normally some support will be super, let me say, I will not call it super, it will be carrying too much moment. You will see in some support having 150 kilonewton meter or 200 kilonewton meter. Such moment, it is large actually. So in order to set your momentary distribution, you can check the drop down list here. We have 0%, 5, 10, 15, 20, 25, up to 30, which is the maximum percentage of momentary distribution at the code stated. When building, it is not more than 4 stories in height. When it is greater than such, the maximum limit of momentary distribution is 10%. Then let us work with 5. Let us work with another 5. Let us work with another 5 automatically. Then you click on OK. So after such, you come and edit the beam details, in which if you are going to work with a rectangle, then you will go. If you are going to work with T-beams, you will go. L-beams, you can go. Let us work with rectangular beam, which is the most uneconomical beam. Then put the width here 225, and then put the depth here 450, and then here it is the standard fire resistance, which is 30 minutes or 1 hour, 60 minutes, 90 minutes, and so on. Beam exposed to fire on 3 sides, check this box. Here, that is the concrete cover, which we are going to work with 25, and then click on OK. After such, you will edit the materials of such beam. This is the density of the concrete. Let us work with 2,400. The grade of the steel, let us work with 410, and then 410. Yeah, this is the size of the aggregate. And then the concrete class, we are going to work with C20/C25. That is a cubic strength of 20 and a cylindrical strength of 25 Newton per millimeter square. You click on this one and then click on OK. Then here there is design option. When you click, this means position of support shear check, where the software is going to start checking the shear for you near the support of the effective depth from the support. Normally some softwares are adopting such kind of things. Even the codes talk about such. You can carry the effective depth from the support inside the span and then start checking the shear at that position or at the support. Then let us work at the support. Zone of mid-span shear check. That is if we are going to limit the zone of mid-span shear check. So we can leave it as default, which is normally the recommended one. Then here maximum allowable distribution, which is 30%, and then we will click on OK automatically. So after such, you can come and visualize the unfactored load on the structure, or you can visualize the load combinations, you can visualize the moment, you can visualize the shear. So if you look at the moment, I don't know what is the problem. It does not put the values here on the moment. So normally I think it is from the software, but when you restart, when you are using it, you will see such. So I just experience it now. I hope you understand much more. So what we are going to do, let us say this is the envelope, this is the load case 2, this is load case 3, that is load combination 3. Then when you come back here, when you click on the first span and click on section design, and then click on search box, you will see all of the informations here. As you see, it does not put any moment, so I think it's from the software, or I have problem from the installations, or there, but I hope you understand what I mean. It will calculate everything for you as we did for the normal other beam design. That is our previous lecture. So everything here is okay. As you see, this box is checked with green, this one also, and then click on OK. Then the information will be displayed here. And then you click on the second span, section design. Then everything will be open, is okay. And then click on OK. Click on this span 3, section design. Then you will see all of the informations there as it is on the previous span. Click on OK. The information will be displayed here also. Here, the output option is to set whether unit summary or none of the outputs, or beam geometry diagram, check the box. On factored loading diagram, check the box. Load combination diagram, also check the box, and click on OK. After you finish, you can click on finish again. It will display everything for you in the blue sheet, and you can visualize everything here, all of the analysis and then the design generated by the software. So I think this is the end of the lecture. So if there is any question, you can ask your question here and I will answer such question. Thank you.